Alright, you guys, for number 6, it's not incredibly hard, but it is incredibly specific. So if you keep in mind one or two things that have to do with the sinusoidal functions or the sinusoidal exercises, I think you'll be good to go, okay? And so a lot of these is just context. If you understand it well, you're good to go. If you've never seen or never reviewed the sine function, there's not much I can do to help you because not even the formula booklet has a lot of tips and tricks here. This is stuff you just kind of have to know, okay? So just a heads up, it's not that hard, but it is very specific, okay? So, number 6. The function f is defined by f of x equals sine qx, which is this guy that you're looking at here. They tell you that q, the guy inside of the parentheses for sine, is positive, okay? The following diagram shows part of the graph of f for these values here. Now, what the heck does this even mean? Well, because there's an x in between it, it's basically telling you, dude, your x values go from 0 up until 4m, which is why in your graph, you go from 0 up until 4m, okay? And so that is how far your x values can go, and that also affects your y values, right? Because you can't have an x equals 5m, you don't actually have a point here for y, see? So that is what they define as domain. And so let's just recall that for a second. Domain is technically your possible x values, okay? While range, you guessed it, is also your possible something, but in this case, your possible y values, okay? So your domain is possible x values, your range is possible y values. Here they define your domain. They also mentioned that x is in radians. Now, what the heck are radians? Radians, whoops, apparently radians is a powerful word. So radians is just a way to express degrees. All right, so let me just give you an example. It'll make a little bit more sense. 2 pi radians, okay, so 2 pi radians equals 360 degrees, while 1 pi radian equals 180 degrees. It might make a little more it might make a little bit more sense if you look at a unit circle graph. So in Google you're gonna find, sorry I had to cough for a second. So in Google you're gonna find a lot of different unit circles. And so for example here, right, you have that for 90 degrees its equivalent in radians is pi over 2. For 270 degrees its equivalent is 3 pi over 2 radians, all right? And as I said, 180 degrees has a single pi next to it. Okay, so that means if you went all around, that means if you went around again with 180, you need to do pi plus pi, you end up with the 2 pi I mentioned here, see? So everyone chill out, chillax, radians is just a way to express angles, okay? And why can this be useful? Because, well, once you memorize the unit circle, which you should for the test, it is an amazing tool which helps for a lot of the steps you're about to see, okay? Anyways, blah, blah, blah. There are x-intercepts at x equals 0, at 2m, and at 4m, okay? So for part A, we need to find an expression for m in terms of q. So first things first, when they say m in terms of q, what this is really telling you is that they need m to be alone. I'm going to be very clear on that. When they say m in terms of q, it means that m is alone, and you're going to end up with a bunch of q's on the other side doing a bunch of different stuff. Maybe it's 2q, maybe it's q plus 7, whatever, okay? M has to be alone, and on the other side, the only variable you can have is q. And so the classic would be y in terms of x. And so an example of y in terms of x would be y equals, because y has to be alone, y equals, I don't know, ax squared plus bx plus c, right? Well, actually, in terms of just x, I could not have a, b, or c. Maybe that wasn't the best example. You would end up with, I don't know, 7x squared plus 4x plus 5. And so, yes, you end up with a lot of different terms, but what would be the only variable? Your only variable is x. You do have a bunch of different x's, but only x. There isn't a, there isn't b, there isn't c. It's only x. So that is what it means when it says m in terms of q. M has to be alone, and you will end up with only q's on the other side. Now, to further understand how to solve this, you first need to identify where q is. And so q is inside the parentheses of sine. Now, if you don't know much about sinusoidal functions, or you didn't review in time or whatever, that is useless information to you. So let me give you a quick review for how sine functions work. Okay, technically a sine function, all right, so I'm just going to write it over here. Technically a sine function will have four different like key values. Okay, you have a, you have b, you have c, you have d. And so technically your sine function, I'm just going to put sine, I don't know, sine x. Okay, a, b, c, and d, enter it in various different ways. All right, on the one hand, you can have an a that is multiplying right outside. Now, A is easier to remember. A will be associated to amplitude, okay? What is your amplitude? Your amplitude is in your sine function, right? For example, here. In your sine function, your amplitude will be how high or low it goes in respect to the x-axis. And so an amplitude here, for example, from here to here, and let's say that this is 0, and then this is, I don't know, 2, and down here would have to be -2, right? And so your amplitude here would be equal to 2, just as an example, okay? The other thing that can happen, all right, is this b. So this b is going to enter inside the parentheses. So your b that I'm about to explain now and explain what it does, the b is the q, all right? So like b equals q in the explanation I'm about to do, okay? So what is b? Well, b has to multiply x inside the parentheses, and there's not a like too much of a clear definition I can give you, but b is like associated to the period. To the period. I'm not saying that it is the period, but it's associated to the period. Why is it associated to the period? Because the formula for period, and this is very important, this is not in the formula booklet, write it down. The formula for period is 2 pi divided by b. This is in radians, by the way. If you want to have it in degrees, you can say 360, as I taught earlier, divided by b. All right, so the period, b is heavily associated to the period. It helps you a lot to find it, okay? And so this is a massive hint for how to, find q in our exercise, but for now, let's move on. B is just sort of associated to the period, right? Think about it this way. If you have a b that is bigger, that means your function is doing repetitions more quickly, right? So this is a bigger b, all right? And a smaller b, like less than 1, means that your repetitions are a little bit longer than before, okay? And so that's the idea. A b that is less than 1 would look something like this, and a b that is greater than 1 would like do its repetitions more quickly, right? That's the main idea I'm trying to tell you guys. Yeah. What else? So c, technically c, would be something like this. C, I don't see it show up too often, I'll be honest. But technically C is something that is adding or subtracting inside, and is what we're going to call a horizontal translation. How can you memorize this more easily? Well, notice that it is adding or subtracting directly to x. And x is associated to your horizontal values, because in your xy axis, your x is horizontal. So whatever is adding or subtracting specifically to x will be a translation to the left or right, okay? And last but not least, for d, you guessed it, it's going to be the vertical translation, okay? And so you might be thinking already, well, if I look at my function here, I have sine parentheses qx, right? And so sine parentheses qx, does it have a horizontal translation? Does it have a vertical translation? And technically I would say yes, but it equals 0. And even for amplitude, it does have an amplitude. Like, what is multiplying sine qx right now on the outside? A 1. There is a 1 hidden right here. And so your amplitude is equal to 1, which is why from here to here, the distance is 1. Ah, look at that. That's why the distance from here to here is of 1. And the vertical translation, the plus d that is like outside, well, here I have a plus 0, right? You have a plus 0, which makes sense because if you look at the like like the line that cuts through your sign, it's actually at y equals 0. So I'm just saying, you guys, that is the context of the stuff that can show up, and more often than not, what you end up using the most in my experience is what I told you for the formula of the period. Okay, so let's go back down here. Let's see how that plays out for our exercise. And so you want to find m in terms of q, and you know that q is associated to the period. So immediately you can already say, right, you can already say for part A that the period equals 2 pi divided by b. And you know that b, from the function that they gave you, sine qx, you know that b is whatever multiplies x inside the parentheses, so period has to equal 2 pi divided by q. All right, now we're getting somewhere. Now we just need to find whatever period is, okay? And so period, I vaguely defined it earlier as like, it sort of affects like how fast or slow you do like these repetitions on your sine function. But maybe a better way to put it, or how I like to, remember it, okay, is that your period is like the distance from max to max. So period is the distance from max to max. Now this is the hardcore definition, but this actually has a bunch of different implications I'm about to show you. And so from max to max, well, if I were to keep graphing this, right, following the pattern that I see, I would need to have a maximum over here, right? And then it would cross again over there, right? And so from max to max, you can think about, so it's from here to here, this is a period, right? And so this is going to be one period from max to max. So you're thinking it's 5m minus 4m. So 5m minus, 5m minus m gives you 4m. I gave the answer out loud. So 5m minus m gives you 4m. So the period over here, we're going to call 4m. So 4m equals 2 pi divided by q. Now, before we move on with the math, let me explain why knowing the period can be very useful. And so the period, as I said, is the distance from max to max. But technically, depending on the exercise, it can also be useful to think about it as the distance from the minimum to the minimum. After all, it's the same, right? If you compare the max to max, it's the same as if you compare from the min to min. And the other cool thing that you can start considering, and I know this is going to be a little bit trippy, but it's very useful to know, okay, is that imagine this red line that I drew, okay? So this red line that I drew, that goes like this for period. Imagine you shift it to the left little by little. So if you shift it to the left little by little, on the one hand, you would end up with something that goes, I don't know, like this. Then you go with something that ends up a little bit like this. And lo and behold, eventually, damn, you end up with something that looks like this. Something that is touching the x-intercepts. Ooh la la, that seems incredibly useful. Maybe not now, maybe for later. And so thinking about the period can be a massive hint. Now, here, technically, it gives you the x-intercept of 0 and of 4m, and there's also one in the middle for 2m. So you gotta watch out for that kind of detail. But you know for sure, the period also helps you find the x-intercepts because the sine function, it goes on like this forever. And so any sort of proportion that you find from here to here, or from, I don't know, there to there, or even from, like from here to here, is something that plays along the whole graph all the time. And so the period distance, it's a cycle that repeats, can be useful to know to find all these different sort of values. The last thing I'm going to tell you, just because the IB loves to, do exercises like this, is that technically here, they didn't give you the other maximum, right? I mean, I drew it and it was very easy to spot what the period had to be, but imagine you didn't spot it. What could you have done? Well, the period, as you can see here, as I said, it's from max to max, but you can also think about it as like, if a period is a distance from max to max, you can also think about it as twice the distance of max to min. And so if you take the distance from max to min, which is usually what they give you actually, just like half a cycle or whatever. So if you think about from max to min, this distance is 3m minus m, it's 2m. But this times 2, you know for a fact has to give you the other max. So 2m times 2 gives you 4m. Okay, so that is another way to find the period. You take the distance from the max to a min and multiply it by 2. All right. Why does this work? As I said, the sine function repeats forever, so all these different properties really start to shine. All right. All right, that's a lot of blah blah, but sometimes you need blah blah in your life, especially for math. So, yeah, deal with it. Anyways, here we are, and here we are almost done. And so you want m in terms of q. That means that m has to be alone. So m has to be alone. How do you get m alone from here? Well, it's being multiplied by 4, so you can divide by 4 to both sides. So that means this goes away with this. M has to equal 2 pi divided by 4q. You divide by 2 on the top and on the bottom. M, whoops, that looks like a very nasty M. So M has to equal pi divided by 2q. So let me put this in light blue just so that we recall what's going on. M has to equal pi divided by 2q, and that is for part A. Then they tell us that the function g is defined by g of x equals 3 times sine, and then parentheses 2 over 3 times q times x. For a new domain, so interesting, so now your function reaches a little bit more. Instead of reaching 4m, it's going to reach 6m. And on the axis above, you need to sketch the graph of g. Now guys, I'm going to mention something right away. Yes, it's a sketch problem, and you might be thinking, haha, easy points, but it's worth 4 points. And so sketching is not only about nailing the visual aspect of how it should look like, it's also nailing what I'm going to consider like key points / aspects, okay? And I'm just going to leave this clear right away because I feel like a lot of people miss points on sketching just because they don't understand that, dude, it's not just about it looking nice, it's about it being accurate and putting the key points and the key aspects. So let me actually show you the answer key for a second. Over here you can see that the 4 points that show up is on the one hand that the scale factor is seen anywhere. So that this is like the part of like it looking it nice. But then you need to be accurate on the amplitude. Then you need to be accurate on the domain. Then you need to be accurate on the max and min and x-intercepts. And so again, this up here is like looks nice, right? But the majority of points is like that it's actually accurate, okay? So careful, you guys. It's not just about drawing anything. It's about drawing stuff that is actually accurate. These points that they're putting here, right, are not just any points. It's the max and min. It's the x-intercepts. And we're about to find out how to get those specific points with certainty, all right? So the main idea we have to like follow through with is that they're asking you to sketch something which looked similar to f of x. So how did f of x look? They gave us that f of x was sine qx. And now they gave us g of x, which is 3 sine parentheses 2 qx divided by 3. And so think about it for a second. What is happening here? Well, on the one hand, my amplitude used to be 1, and now it passed to be 3. So that's the first thing I need to observe for part B. The amplitude, remember that amplitude is whatever is in front of your sine, right? So your amplitude now is going to be 3. So first thing first, amplitude equals 3. The other thing you can observe is that now your period is not just q, it is 2q divided by 3. And so your new b, which is going to affect your period, it has to be 2q divided by 3. Before your b was just q, now it's 2 over 3q. Everything else is the same. And so you have a new amplitude, and you have a new b, and you just see how this affects your max, your min, and all that stuff, right? Now, I did tell you guys earlier that if your b is greater than 1, your frequencies happen like faster, right? And if your b is less than 1, but also positive, I forgot to mention this, less than 1 but also positive, you end up with a period that like takes longer to happen, right? And so from here, your new b is 2 over 3. So that is a little bit less than 1, but it's still positive, and so your period will take longer to occur. Okay, so that means this maximum here is probably going to be, I don't know, somewhere over there. Okay, so it's going to take longer to occur the maximum and longer to occur also the minimum. Okay, and so everything is going to be like a little bit more delayed, if you want to think about it that way, because your value for b is less than 1 compared to before. See? I mean, it's less. Okay, it's less. All right, anyways, so I think the most important thing that you can do is always going to be apply the period formula. And so you apply the period formula from here, the new period, so let me just go like this for a second. So the new period has to be, well, you don't figure it out yet, right? And so the new period, well, we're going to put period equals 2 pi divided by b. Now b, we said was 2q divided by 3. And from here, you're working with fractions in a very nasty way. What I suggest that you do is that this numerator, you can put it as 2 pi divided by 1, and on the bottom, you leave it as 2q divided by 3. All right? I like to think about it this way because technically from here, you can say, so because this is like a big division symbol here, you can think about it as 2 pi over 1 being divided by 2q over 3. And when they divide like this, you end up with 2 pi over 1 times the reciprocal, 3 over 2q. And so 2 pi is going to multiply 3, and 1 is going to multiply 2q. Right? This is just how you handle big fractions. Now notice, here's something interesting. The last, and this is like a math tip, okay? So the last step you reach is 2 pi times 3 and 1 times 2q. And so something very visually appealing when you have big fractions like this is that the 2 pi times 3 up top are the extremes multiplying each other, while the 1 times 2q are the ones in the middle multiplying each other. Interesting. And so you can just do like the edges times the edges and the inners times the inners, and you get the same result. And so that's how I like to do it. I think about the edges times edges and the inners times inners for big fractions. Okay, whatever, to each their own. See, point is, you're gonna end up with 6 pi divided by 2q. And so period, right? Let me just be a little bit more organized in my approach. So period, as I was saying, has to equal 6 pi divided by 2q. Now you can divide by 2 on the top and on the bottom, and so period has to equal 3 pi divided by q. Now q is a little bit hard to read, and it's actually not that useful. It would actually be more convenient if you replaced q with something that you can read. For example, m. Your whole x-axis is detailed with a bunch of m's. And so if you put this in terms of m, it's actually going to be a little bit more friendly to be able to read. And so lo and behold, what you need in part B comes from something you did in part A. So from this here, from part A, you can get q alone. And so you can do 2mq equals pi, right? If you multiply 2q to both sides. So this goes away with this. And if you get q alone, you can say that q has to equal pi divided by 2m. And so on. Now this I can plug it in over here, and you end up with 3 pi divided by pi divided by 2m. And here I do the big fraction tip, so 3 pi divided by 1 divided by pi divided by 2m. I do the extremes multiplying each other, so it's 3 pi times 2m divided by 1 times pi, so just pi. Now, because it's all being multiplied, this goes away with this, and the period, period finally becomes into something more readable. Period has to equal 6m. Okay, so your period is 6m, and this already gives you a whole point, okay? Now, remember how I mentioned earlier that the period, you can think about it as max to max, right? Or you can think about it as min to min, right? You can also think about it as from min to min. Well, you can also think about it as, I mean, the actual math definition is max to max or min to min, but you can also think about it as x-intercept to x-intercept, right? Because it's all sort of parallel in a certain way. And so from here, what you can say, technically, right, is that because your period is 6m, right, you need to have an x-intercept here, right? So if you have an x-intercept here, you also have one over there. Now, you know for a fact you have one over here, and this is important, right, for the implication I'm doing. You know you have one over here because there wasn't any horizontal translation. If there would have been a horizontal translation, your first x-intercept of equal to 0 would have shifted, right? If you had a horizontal translation a little bit to the right, then your new graph would have had a different x-intercept. But because there wasn't any horizontal translation, you know for a fact, this is the right way to think about it, you know for a fact you have an x-intercept here because there was no horizontal translation. Because of the new period, you know for a fact there has to be an x-intercept all the way over here because this point repeats in 6m again, and that would be over there. That's the idea of the period. Like if your period is 6m, whichever point you look at, its height will repeat in 6m more units, or in that period amount of units, okay? So if you have an x-intercept at 0 and the period is 6m, you need to have an x-intercept at 0 plus the period, so 0 plus 6m, right? Just going to be 6m. All right, enough blah blah. That is one way you can identify some of the x-intercepts you need. So starting from there, we have something, right? The other thing we need to acknowledge, right? And so the other thing we need to acknowledge is trying to find which, like, is the x value, okay, of my maximums and minimums, okay, which is also going to be a big hint to see if you have another x-intercept in between. And so right now, for example, in the original one, you knew that the amplitude was 1, and so all the maximums and minimums had to be at a height of 1 or -1, right? For a fact. And so from here, well, you know that the amplitude is 3. And there wasn't a vertical translation, so the maximum or minimum only depends on the amplitude, right? If there would have been a vertical translation up here of like +1, and then another amplitude change, then yeah, you would need to consider like a different sort of approach. But right now, the only thing affecting my maximum y value is the amplitude that like appeared. And so because the amplitude over here equals 3, that means that your maximums for this new graph are going to be at 3 for a fact, or they're going to be at, for the minimum, at -3. All right, and now we're getting somewhere, right? And so basically what you can do from here is that you can say, okay, so I want to find the x value of the maximum, right? And so you know the maximum is somewhere at y equals 3, right? And so if you plug in y equals 3, you're going to be asking your function, where is my maximum, right? So if you take g of x, so you know that g of x is, you know, maybe something with more space. So you know that g of x from the exercise is 3 sine 3 times sine 2qx divided by 3. And so the moment you plug in 3 for g of x, you're plugging in the y equals 3 I mentioned earlier. And so you're asking your function, when y is 3, what is x? Okay, and the moment you find your x value is the moment we can really plug in like the maximum point with more accurate description. Okay, so that is what we're trying to do. You're trying to find the exact x and y coordinates of your maximum. So if you plug in 3 for y from here, you can end up with 3 equals 3 sine 2qx divided by 3, right? Now from here, you want to get your x value alone, right? Or leave it into something a little bit more readable. So first things first, you can divide both sides by 3. So you end up with 1 equals sine parentheses 2qx divided, all of this divided by 3, right? Now, the most annoying thing from this step right now is that you have a sign going around. So guys, how do you get rid of sine? What is the opposite of sine? The opposite of sine is sine inverse. So if you do sine inverse to both sides, you're going to end up with this going away with this, and so sine inverse, sine inverse of 1 is going to equal 2qx divided by 3. All right, and here's something I need to mention, like more from a conceptual stand of view. Whenever you do sine of something, as you can see, you get rid of sine and end up with only what's in the parentheses. But there's something I need to like point out that's very, very important. Okay, whenever you use sine, and this actually does show up a little bit from the booklet, so just as an example, whenever you use sine, remember or look, it's always like sine theta, right? And so what is theta? Theta is a way to express angle, okay? And so theta is an angle. The sine always has sine, like whatever's inside the sine, this is what I'm trying to tell you. Whatever's inside the sine is an angle, yeah? And so from here, when you do sine inverse, you end up with just the angle of 1. And so basically, this right here, although it sounds kind of crazy, is trying to, it's asking like, what is the angle at sine of 1? That is what it's asking for. What is the angle at sine of 1? And angle in terms of radians, because this whole exercise has been done in radians, okay? And so that is a weird question to ask, but that is why earlier I said, dude, if you know the unit circle, you're good to go. And so sine, right, we have associated sine and cosine and tangent to the famous so, ka, toa. And so ka, toa, the so is telling you opposite over hypotenuse, the ka is telling you adjacent over hypotenuse, and the toa is telling you opposite over adjacent. And so your unit circle is actually filled with a bunch of different triangles, see? So actually, if you go ahead and draw the unit circle just for a second here, right? So if you draw the unit circle just for a second here, you're going to notice that there's a bunch of different triangles that show up in all these different sort of key angles that they're throwing at you. And there's one key thing you have to acknowledge. The unit circle, what dimensions does it have? What dimensions does it have? This point here is 1, 0. This point here is 0, -1. This one is 0, 1. Sorry, that could not have been more wrong. This point here is -1, 0. And wow, I'm on a roll today. This one is 0, 1. Okay, so this one is 1, 0. This one is 0, 1. This one is -1, 0. And this last one is 0, -1. Okay, that makes more sense. And so from here, you're telling me that the radius is equal to 1. In all of these, the radius equals to 1. In all of these key different triangles that they're throwing at you, the radius equals 1. So all of these hypotenuses are equal to 1. Right, that's interesting. And so when you have a sine of 1, well, the hypotenuse equals 1. And so all this is really telling you is that the opposite equals 1. And what is the opposite in all of these triangles? The opposite of all of these triangles for a sine that's going over here, well, the hypotenuse is 1, and the opposite will always be, because it's the vertical like sort of growth, the opposite will always be the y value. So you gotta go to your, what this is telling you is go to the unit circle and find the y value that equals 1. And so the y value that equals 1 is this guy up here. And what is the radian associated to it? Pi divided by 2. That is what sine inverse is doing. Okay, that is what it's doing. And so from here, well, basically, this whole thing on the left is just going to turn into pi divided by 2 equals 2qx divided by 3. Now from here, get x alone. And I know we have a q going around, but I'll explain how we handle that in a second. Just for now, okay, get x alone, see? And so the first thing I would suggest that you do is that you can multiply by 3 to both sides, okay? So you multiply by 3 to both sides, this goes away with this, you end up with 3 pi divided by 2 equals 2qx. So from here, you can divide by 2q to both sides. That means you end up with 3 pi divided by 4q equals x. Now, this is not a good enough x value for us to read because our thing isn't, our x-axis is only in terms of m. It does not have a q in between, so it's very, very weird and confusing. But lo and behold, once again, part B needs something from part A. And so earlier we said that q can be written as pi divided by 2m. So we're going to do that once again. So q equals pi divided by 2m. That means that over here you end up with 3 pi divided by 4 times pi divided by 2m. All of this equals x. So let me simplify what's on the bottom first. So you end up with 3 pi divided by 1 divided by, this goes away with this, you end up with 2 pi divided by m. So all of this equals x. You can multiply the edges with the edges. So it's 3 pi times n gives you 3 pi m. And then the inner with the inner is 1 times 2 pi, so it's going to be 2 pi. All of these equals x. You can divide or get rid of pi on the top or the bottom. So x equals 3m divided by 2. And this, ladies and gentlemen, let's recall, comes from the fact that at some point, where is it? Here. That at some point, you plugged in 3 for y. So you were asking your function, yo, when y is 3, what is x? And why did we choose 3? Because the new amplitude from here was 3, right? So the new amplitude was 3. So that means the maximum has to be at y of 3 and then x of, as I discovered, and then x of 3m divided by 2. And so at 3m divided by 2, so 3m divided by 2 is the same as 1.5m, right? And so 1.5m, which is right around here, is where you're going to have your maximum, okay? So boom, we finally got one of our key points. But from here, everything is just kind of like smooth sailing. And so from here, that means that my function for g of x is going to look initially like this, okay? And now we need to see where it might touch, like for the x-axis, right? Now, to further understand that, let's take the following idea. From 0, in the original one, right, the black line, from 0 to m, you first reach the maximum, and then you would add another m, right? So from the distance from 0 to your max, you add this distance again in order to reach the x-axis, right? And so if you take this 1.5m and you add that distance again, right? So this adding itself again, you end up at 3m. And so at 3m, you need to have one of your x-intercepts. And so, okay. So that means that for g of x, you have your maximum here. Then you cross the x-intercept over there. And then you add another 1.5, right? So you add another 1.5, that means you end up at 4.5. So at 4.5 is when you're touching for your minimum. Because as we said, the max and minimum have to be at 3. And all the process we just did was for finding the corresponding x values. See, so over here, I'm going to go ahead and write 4.5m, okay? That means I have a minimum, sorry, over here. And if you continue with this logic, lo and behold, you're going to end up with an x-intercept right there. So ladies and gentlemen, that is the appropriate way for graphing and sketching for number 6. I don't think it's incredibly hard, but you do need to be very conscious of the different tools, and especially the tools that are not in the formula booklet. I think understanding the context of what A, B, C, and D does is massively important, and just as a hint, I've seen that it's extremely important for you to know well the formula for period, okay? Know the formula for period, you pretty much always have to use it, okay? Ladies and gentlemen, that is how you do number 6, and I hope it helped.